Hi, everybody. Let's talk about the basic calculus in terms of integration. I will start with looking for the area under the curve of linear. In this case, is the right triangle, as well as the area of a disk. Okay, let me see. All right. Sorry, my camera is not stable because I use one hand to, holding the smartphone and the other hand is like point out what I'm talking about. Okay, let's start with the area of the right triangle. You know exactly that's the area of the triangle is the 1 over 2 multiplied by the width. In this case, is the base multiplied by the height. Okay, so that's going in this case going to be 1 over 2 a b. All right, that's the area of the right triangle. Now let's recall about the integration, finding the area of whatever, under the curve. That's you need to divide uh, the triangle into smaller elements, and the very very small area of the rectangular is the width multiplied by the height. In this case, the width is dx and the height is the y. So you end up with ds equal to y dx. Next, you need to write y in terms of x because you're going to integrate it with respect to the x. For the linear, you have a linear equation y equal to mx plus c, right? Where m is the slope, which is equal to delta y divided by delta x. And delta y, you have a rectangular coordinate here is the a or xy, a, b. And at this point, you have a 0 and 0. So your slope is going to be b minus 0 divided by a minus 0 equal to b over a. This is your slope. Now for c, you apply the condition at x equal to 0, y equal to 0. So you have c equal to 0. You end up with the linear equation y equal to bx over a. Then your ds equal to bx over a dx. You do the closed surface integration is equal to integrate ba. This is your y, right? And dx. You have a lower limit 0. And you have upper limit it's a, because you start from x equal to 0 to a. Okay. And this is the very simple integration. So you end up with x to the power 1 plus 1 divided by 1 plus 1. So you have x squared divided by 2. And then you apply the lower limit and upper limit. A cancel out. You have a left. So you have 1 over 2 ab as in 1. Okay? Just you might see this one is very simple, but we have something more than that because we recall so many things, the basic of our math. Let's move to the area of a disk. All right, let's see. area of a disk. You have a disk with the radius of a, and the area is actually is simple pi a squared, where a is the radius of the disk. Now let's do the calculus, do integration. You know that you're going to divide the disk into smaller elements with the width of the x and the height actually is 2y. Why I have 2y? Because I start from y equal to 0 to any y, and then this is the symmetry. So like it's just a mirror. So I added up, I multiply y by 2. So you will have the total area of the disk, the whole disk. So the s equal to the width, that's the x multiplied by the height, that's 2y. And you have y equal to square root x squared minus x squared multiplied by the width. And your total area of the disk, you simply do the closed surface integration. You end up with 2 integrate of a squared minus x squared to the power 1.5 dx. And you apply the lower limit and you apply the upper limit. So you will integrate, from x equal to negative a to positive a. So that's why I have the lower limit negative a and upper limit a. So you will see that the following steps, you are going to recall so many math basic, and you will use this in the future for the calculation, especially for integration deeper and deeper. Okay, and you can see that your job is that to find the integration of this term. You need to apply trigonometry. So we're going to, the power 1 over half or the square root. So we're going to move into trigonometry. We let x equal to a sine theta, and you're gonna switch from dx to d theta because we are going to dealing with theta. Your dx with respect to theta, that's going to be a cosine theta because the differentiator of a sine theta, you end up with cosine theta. And then you can write dx in the term of d theta, that's equal to a cosine theta. Okay? And the term a squared minus x squared, that's going to be a squared. You just plug in x equal to a sine theta. So you have a squared sine squared theta. And you have a 1 minus sine squared theta. That's the cosine squared theta. Because you know that the sine squared theta plus cosine squared theta equal to 1. Then the term a squared minus a squared sine squared theta to the power 1.5, you end up with, this is your dx, right? Dx equal to, in the term of d theta, that's the a cosine theta, d theta. And a squared minus a squared sine squared theta, 1.5, you end up with cosine squared theta, d theta. Now, you're looking for integration of cosine squared theta, d theta. You make another move. Okay, let's start with the limit of integration first. You integrate of dx from the lower limit, negative a, to the upper limit of positive a. For x equal to negative a, that's equal to a sine theta. So your sine theta equal to negative 1. then your theta is equal to negative pi over 2. And for x equal to positive a, your side theta equal to 1, and then your theta equal to pi over 2. Okay, so you have a lower limit of theta and d theta, and then upper limit of d theta equal to pi over 2. So you have something like this. Now you have to dealing with integration of cosine square theta d theta from the property of cosine a plus b. That's going to be equal to cosine a cosine b minus sine a sine b. And you have a cosine 2 theta, right? So that's the cosine theta plus theta. You end up with you apply this property, you have a cosine theta square minus sine theta square. And you write everything in the term of cosine theta. You know that sine square theta equal to 1 minus cosine square theta. And then you can write cosine 2 theta in the term of cosine theta. And cosine square theta equal to 1 plus cosine 2 theta over 2. Now, this is your cosine square 2 theta. And then you integrate with respect to d theta. This is your lower limit, negative pi over 2. And this is your upper limit, pi over 2. And then, 2 cancel out. You end up with the integration of this term, integrate over d theta plus the integration of cosine 2 theta d theta. So you apply upper limit and lower limit. That's equal to pi over 2 minus pi over 2. Because this one, you integrate over your d theta. That's give you only theta, right? And you integrate over cosine 2 theta. You have sine 2 theta over 2. You can check it back. If you differentiate this term, you should end up with cosine 2 theta. So when you differentiate sine 2 theta, you have cosine 2 theta, and you also differentiate 2 theta. That's give you 2 cosine 2 theta, and you already have divided by 2. So 2 and 2 cancel out. You end up with cosine 2 theta. Okay. And then your total area of the disk equal to pi a over 2. As you know that the area of a disk with the radius a, that's the pi a squared. And if you take another way of integration, you look at the cylindrical coordinate. That's in the term of r, phi, and z. And ds, you do the same thing, equal to the width multiplied by the length. And the width is actually dr. This is a cylindrical coordinate, right? And the length equal to 2 pi r. You have the radius r. So the radius starts from 0 to a, right? The maximum, that's the radius of the disk. You can see that this is your ds equal to dr, the width multiplied by the length. That's the 2 pi r. And you apply the lower limit, r start from 0 to a. And then you integrate r dr. That's give you r squared divided by 2. And you apply lower limit and upper limit. Then you end up with a is equal to pi a squared. That's the area of the disk. Okay. And next, we will move on talking about the coordinate systems. You have a rectangular in the term of x, y, z. You have a cylindrical coordinate in the term of r, phi, theta z. And the last one is the spherical coordinate in the term of phi and theta. Basically, when you study um, any courses, especially for electromagnetic, you know that you need to apply a lot of math to overcome problems. And you have lore, you have theory, but to overcome problems, you need to apply a lot of math. And if you don't have strong background in math, you will have a difficult time or the tough time to dealing with their problems. Okay, that's all for now. Bye.